macrophages, they can take the little membrane that's getting broken apart, they can digest it. We begin to separate the heme from the globin. So those little 4 protein chains, and the heme that's in the middle of them, they get broken apart. The globin was simply the string of amino acids making up that hemoglobin protein. So the globins get broken down. What does it mean to hydrolyze? Hydro. Water. Lyse. What? Huh? Water. Breakdown. So those amino acids that are chained together, water molecules come in, provide some H's and OH's, and break them apart. Okay? Now, we break those amino acids. Well, guess what they get to do? Do we lose them? No, because they're too important. The body does not store amino acids. So they move back into the bloodstream, go back to the cells that need them, and they're used again. We have the heme group now that we got to deal with. The heme group has the iron. So we need to take the iron off the heme. Because if we already don't probably have enough of the iron, we need to do something with that, right? So what do you think we're going to do? Well, we can't break it down. It's in its smallest component. We can take it and we can either reuse it in the blood cell production that's taking place, or we can store it in the liver. Remember how it can be stored in the liver? So now we got to take care of this little heme group. The heme group, you got to love it. All right? Heme, now watch. Converted to biliverdin, which is going to be green in color. Biliverdin converts to bilirubin. Have you ever heard of bilirubin? How? Huh? What? Jaundice. Yeah, you know, happens a lot with little itty bitty babies. Okay? Then, you know, they got to put them under a light, and they hate that, you know. Then, as we're sick or something like that, it can be a problem. What's really being affected here with the jaundice? Your liver. That's really being affected. Okay? I didn't know there could be jaundice in your dog. Okay? I learned something new back in the springtime. I have a pug, very spoiled, okay? She, however, she's now going on 13 years old, and in that time frame, for me, she's genetically predisposed to bladder stones, so she's like had her bladder operated on 4 times. And then, back in April, she got really sick. And when she didn't eat, oh, I knew something was wrong, okay? Because, I mean, you can't have a piece of food and not have her eyes looking right at you, okay? Now, when she didn't eat, she wasn't getting up, she wasn't going to the bathroom, but I missed the yellowing of her eyes. Because, you know, a pug's eyes are so big, you see very little of the white of her eye. Well, I knew something was wrong, so I immediately, you know, get her in the car, take her up to the BRCC up in Mannequin-Sabot, and they did a couple of like preliminary tests, and they're like, you know, we really need to keep her overnight. She's very dehydrated. We need to get her some fluids, and then we'd like to run some more tests on her tomorrow, like ultrasound and stuff like that. Her gallbladder. Never knew that could happen. But it had gotten so inflamed, so enlarged, it was now affecting her liver. And it was making her jaundice. They said in another week, if I hadn't brought her in, she probably would have been dead. So, you know, they had to do emergency surgery, remove the gallbladder. She ended up staying in the hospital for like 4 days up there. And she just, you know, I was like, this can happen with a dog? So, yeah, I was like amazed at that. So the bilirubin can be very indicative of stuff because it turns the yellowish, meaning most likely the liver's not functioning correctly, because the liver removes bilirubin and secretes it into bile. When that happens, concentrated in the gallbladder, released into the small intestines, with the help of some bacteria, they convert it into urobilinogen, which becomes a part of our feces. It's what gives the color to the feces when we break it down. So this is what sort of happens in this life and death of the erythrocytes. These lovely little red blood cells that we definitely need. I can't imagine life without them. Don't want to. But there are issues that happen with the red blood cells. Some of the disorders, polycythemia, an excess of the red blood cells. We can have either primary or secondary polycythemia. The primary, there's usually some type of cancer that's present, and that is going to affect the production of those red blood cells. We can get counts that are completely off. It can make up to 80% of the hematocrit. Do you guys remember in the test tube, spun it down? How much, what's the normal count? Roughly 45%. So almost twice your blood could be the red blood cells, and that's not healthy. Secondary. This is what happens when we get dehydrated for the most part. When we get dehydrated, there's not enough water into the plasma portion of the blood, and it makes the blood thicker. It makes the hematocrit count be higher. However, get the fluids back in your body, chances are you're going to be okay. But in the meantime, while that's occurring, okay, you are actually putting more stress on other areas of your body, especially your heart. So still not a good thing to do. When we have these disorders of the polycythemia, blood volume, pressure, viscosity, they're going to all be affected. The results, you could have an embolism, stroke, or heart failure. So it's not really something that is, I guess, a good thing to have. Like I said though, if it's secondary, just make sure you get plenty of fluids. And that usually happens day to day, all right? Another problem is anemia. This one is very common. It happens with a lot of people. There are basically 3 categories of anemia: inadequate red blood cell or hemoglobin synthesis. Hemorrhagic, somebody who's had maybe some trauma and they're bleeding. Hemolytic, ooh, not good. okay? People who have a hemolytic anemia, I don't think the prognosis is very good for people with that because it's actually destroying the red blood cells. If we look at the one that's a little common, more common, look what can happen. We can have kidney failure. We have problems with erythropoietin production. We get an iron deficiency. Now, under this inadequate production, we can have pernicious, hypoplastic, or aplastic anemias. Pernicious, autoimmune. People can be diagnosed with this, and basically your own body is attacking the tissues. It attacks the stomach tissue, and there's an inadequate B12 absorption, meaning that affects the production of the hemoglobin. Now, if people get diagnosed with this, I think if they take a B12 shot every day, it usually corrects itself. They're usually okay, as long as they continue to take the B12 shots. A hypoplastic, not enough. We're just not getting the production of the red blood cells quick enough. Aplastic, people usually die from this one because there is a stopping totally of the production of the red blood cells. And without the red blood cells, we're not getting oxygen to the tissues. You know the drill. The consequences: tissue hypoxia, not enough oxygen, and if we don't get enough oxygen to the tissues are going to die. So therefore, the necrosis. Usually some of the symptoms: patient is very lethargic. They usually have shortness of breath. If you tell them to walk across the floor, for example. In some cases, it can be just getting them to stand up can lead to the exertion. This is definitely life-threatening because the brain is not getting enough oxygen, the heart is not getting enough, the kidneys are not getting enough. Those three shut down. I don't think that's a good outcome, just saying. The osmolarity gets reduced, therefore affecting the water movement. We get a buildup of edema. Now, buildup of edema. Why would that be an issue? Well, it's too much fluid. When we hear that, though, how do we normally think about it? Where? We think of it in the feet, legs, right? Can it occur other places? Yes. Yes. Get that fluid on the lungs, get that fluid on the heart, you got some problems. All right? Viscosity, that means the flow of the blood. We affect that. You're putting more pressure on the heart. Now, I want you to remember that because that's going to come back to bite us when we start talking about the heart. Okay, viscosity is going to become very important. Something else that's common, sickle cell disease. Do you know anyone who suffers from sickle cell? What happens?